السلام عليكم ورحمة الله وبركاته. أبنائي وبناتي حبايبي طلاب الصف الأول الثانوي، إن شاء الله النهاردة هنبدأ نحل مع بعض أسئلة Brilliant in Chemistry. ده إعداد دكتورة شيرين خميس. إن شاء الله هنبدأ حل الأسئلة بتاعتنا. إحنا عايزين نتفق على حاجة مهمة جدا. كل ما نبدأ من أولى ثانوي نبدأ نحل الأسئلة القوية أو فيها درجات صعوبة عالية. ده بيسهل لنا بعد كده ان شاء الله لما نوصل تالتة ثانوي في الكيمستري ان احنا نبقى مرتاحين، ما يبقاش عندنا مشكلة في فهم السؤال ولا في طريقة الحل ولا طريقة التفكير. طب اللي احنا بنعمله ايه مع بعض؟ اللي احنا بنعمله مع بعض ان احنا بنشوف السؤال، نقراه مع بعض ونفكر فيه ونشوف طريقة الإجابة بتاعته والتفاصيل اللي خلتنا نختار الإجابة الصح. دي الطريقة اللي احنا هنشتغل بيها، واتمنى ان كلكم ان شاء الله تحلوا معانا الأسئلة هتكون موجودة في بوكلت. اللي يحب يكون البوكلت معاه يبعت لينا على رسائل الصفحة. يعني إن شاء الله كل ما تكون الأسئلة كتيرة هنبدأ نحل أجزاء منها مع الوقت. أوكي، نبدأ مع بعض بأول سؤال. أول سؤال بيقول إيه؟ Which of these statement doesn't describe the conservation of energy in a chemical reaction؟ أنا عايزة، إحنا لما شرحنا قلنا ال conservation of energy هي عبارة عن إيه؟ مين في دول في الجمل دي كلها ما بيعبرش عن، أنا في كلمة doesn't هنا معناها إن ده مش عندي في الجملة اللي غلط هي اللي هتكون إيه؟ اللي أنا هختارها. طيب تعالوا نشوف أول جملة بتقولي إيه؟ Energy is neither created nor destroyed during a chemical reaction. طب ما دي بتعبر عن جزء من ال law of conservation of energy. تمام. The energy contaminated أو contained in the bonds of reactant molecules always equal the energy contained in the bonds of product molecules. Okay. طيب ادي الجملة number 2. number C. If the energy of system increases then the energy of surrounding decreases by exact same amount. برضو دي بتعبر عن conservation. طب عندي energy can only be transferred from one form to another. مش عارفين. طيب number E. If the energy of a system decreases then the energy of surrounding increases by the same exact amount. طب احنا عندنا الجملتين C و E عكس بعض والاتنين بيعبروا عن نفس الحاجة، فالاتنين معانا بيعبروا عن conservation of energy. السيستم بيزيد، السراوندنج بيقل، السيستم بيقل، السراوندنج بيزيد بنفس الاماونت، يبقى احنا كده بنتكلم في conservation of energy. طيب احنا لو فكرنا كده بصوت عالي ايه اللي ينفع الإجابة بتاعتي؟ هلاقي ان الإجابة بتاعتي energy contained in the bonds of reactant molecules always equal the energy contained in the bond of product molecules. ليه؟ عشان دي ما بتعبرش عن تحولات، انا بقول الطاقة اللي موجودة في البوندز بتاعت الرياكتنت موليكولز equal للطاقة اللي موجودة في البرودكت موليكولز. طب هل في حد اتحول للتاني؟ لا، انا بقول ان ال law of conservation of energy كان بيقول ايه؟ the energy in any physical or chemical reaction neither be created nor destroyed but it can be converted from one form to another. ده ال conservation law of energy. طب تعالوا نقول تفاصيل اكتر على الجزء ده. بيقول لي ايه ال law of conservation؟ قال اللي انا قلته حالا اللي هو energy is neither created nor destroyed during a chemical reaction. الانرجي اللي موجودة في البوند بتاعت الرياكتنت molecules مش always equal the energy contained in the bond of product molecules. حد فيهم بيبقى اكتر من التاني، يا اما بتاعت الرياكتنت يا اما بتاعت البرودكت. ما انا عشان اكون برودكت بدي انرجي للرياكتنت عشان تقدر تتكسر وتعمل لي البرودكت، وبالتالي منطقي جدا ان هما واحد فيهم هيزيد التاني هيقل. فما ينفعش ان يكون البوندز او الانرجي بتاعت البوندز بتاعت الرياكتنت هي بتاعت البرودكت. مش منطقي ان هما الاتنين يبقوا ايكوال، لازم حد فيهم بيقل والتاني بيزيد. This is because can be absorbed or released during the reaction which is why reactions are classified as exothermic release energy or endothermic absorbing energy. يعني حد فيهم بديله energy عشان يعمل الرياكشن ده بقول عليه اندوثيرميك او absorbing energy. حد تاني بيخرج لي انرجي نتيجة الرياكشن، وبالتالي هو مش هيبقى equal في الاتنين زي بعض. doesn't always equal. ما ينفعوش يبقوا equal. الجملة اللي عندي في السؤال ان هم equal، لا هم اصلا ما ينفعش يبقى equal. The other statement correctly describes the conservation of energy in a chemical reaction. Energy neither created nor destroyed during a chemical reaction. If the energy of a system increases, then the energy of surrounding decreases by the exact same amount. If the energy of a system decreases, then the energy of surrounding increases by exact same amount. Energy can be only transferred from one form to another. So these statements are constant with the law of conservation of energy, which states that the energy can change form, but the total energy in a closed system remain constant. This is the first question, and the details for the answer and thinking of it. Let's going to question 2. Question 2 says that the space in which a chemical reaction takes place is known as the system. What is the name of the space where heat energy is absorbed from or released into? Okay, we have choices here. We have 5 choices. The first one, atmosphere, background, perimeter, void, and surrounding. Okay, لو فكرنا في كل حد فيهم، أنا قلت هنا ان الفراغ اللي انا بيحصل فيه الرياكشن او المنطقه اللي بتحصل فيها الرياكشن اسمها سيستم. طب المكان اللي بيحيط او اللي بيدي الانرجي للسيستم بتاعي او بيخرج لي انرجي absorb or released الانرجي دي اسمه ايه؟ طيب تعالوا نشوف الاجابه هيبقى اسمه ايه. surrounding. هيبقى اسمه ايه؟ surrounding. طب هو انا اخترت surrounding ليه يا سنه اولى؟ تعالوا نشوف. احنا بنقول السبيس where heat energy is absorbed from or released into during a chemical reaction is called the surrounding. طب السيستم هو السبيس where the chemical reaction takes place and surrounding are the environment around the system. So the correct answer will be letter E, surrounding. The other option not correctly describes the space where heat energy is exchanged like atmosphere, background, perimeter, and void. So these options are not specific to the context of the heat exchange during a chemical reaction. So we concern about the surrounding, and it is the area or space around the system that make exchange or release energy or absorb energy to the system. Okay, let's go into question 3. Question 3 says that the chemical equation for the decomposition of magnesium carbonate is as follows. We have MgCO3, it is a solid, and so if we want to make a thermal decomposition, so we make or giving energy or heat to the substance, heating it. So we give it a amount of joule equal 117 kilojoule. Okay, to get magnesium oxide and carbon dioxide. Based on this chemical equation, which of the following statement is true? Okay, we have different choices here and we want to know. Okay, if we make a balance to this equation, we find it is balanced equation. We have 1 Mg and 1 Mg as product, 1 carbon and 1 carbon, 3 oxygen atoms here and 3 oxygen atoms at the reactant. So we have choices here. 117 kilojoule of energy is released when a single molecule, so it will released when a single molecule of MgCO3 decompose. Do you think that? The next one, 117 kilojoule of energy is needed to make 1 mole of MgCO3 decompose. Do you think that? Okay, let's continue. 117 kilojoule of energy is needed to make 42 gram of MgCO3 decompose. Okay, we didn't have any masses here, so it will be neglected. 117 kilojoule of energy is needed to make single molecule of MgCO3 decompose. Single molecule. Okay, it depends on the kind of compound. Do you think it's it's what? It's ionic or covalent compound. So we will make it depend on the kind of compound. So we have two choices here, we can neglect them. Okay, last one here we have 117 kilojoule of energy is released when 1 mole of magnesium carbonate decompose. Okay, do you think the energy released, all of the energy released? Not letter A and letter E is out of our choices. Okay, let's going to know what we will choose. Okay, so here at first we have a kind of compound, it's ionic compound. So the first one here, single molecule, and the letter D, it's not, it's not what, it's not our choices at all. Okay, if we can think about letter C, we have here 42 grams. It may be, but it also we didn't have any masses here to calculate the mass of the compound here. And also it make a thermal decomposition, so it will not release any energy. So we can neglect A, C, D, and E. So the first, or the suitable choice here, we have 117 of energy is needed to make 1 mole. We have 1 mole here, as we make a balance to the equation of magnesium carbonate decompose. Okay, so in details, if we make a thermal decomposition, so at first, in details for this reaction, energy change or decomposition of magnesium carbonate is an endothermic process because it requires an input of energy equal 117 kilojoule. So the reaction absorbs heat from the surrounding, causing the temperature to decrease. And the reaction details. What happened to magnesium carbonate? Magnesium carbonate, when it heated, leading to its breakdown. So the product will be magnesium oxide and carbon dioxide, and the balance indicates that 1 mole of magnesium carbonate decomposes to form 1 mole of magnesium oxide and 1 mole of carbon dioxide. Therefore, the coefficient represents the ratio of moles involved in the reaction. And the energy requirements, the energy change, 117 kilojoule, correspond to the decomposition of 1 mole of magnesium carbonate. It doesn't apply to individual molecules or specific masses. We didn't mention in the question any masses, or we have a molecules, we have moles, we have only mole of the compound. Based on this information, let's address the given statement. Letter A, 117 kilojoule of energy is released when a single molecule of magnesium carbonate decomposes. False. Why? As the energy is required for decomposition, not released. Letter B, 117 kilojoule of energy is needed to make 1 mole of magnesium carbonate decompose. True. The balanced equation confirms this. Okay. Letter C, 117 kilojoule of energy is needed to make 42 grams of magnesium carbonate decompose is false. We needed to convert grams to moles at first using the molar mass before applying the energy value. Letter D, 117 kilojoule of energy is needed to make single molecule of magnesium carbonate decompose. False, as the energy applies to moles, not individual molecules. Okay. The last one, 117 kilojoule of energy is released when 1 mole of magnesium carbonate decompose. Also false, as energy is absorbed during the decomposition. Okay, let's go into the next question. We have question 4 here. Question 4 says that we have equation for the glucose. We make a composition for the glucose, C6H12O6 plus 6 oxygen moles here to give 6 moles of carbon dioxide, 6 moles of water, and energy equal to 1808 kilojoule. How much energy is released when 2.5 moles of glucose are burned? Okay, and we wanted the energy in what? In kilojoule. Okay, if we have here 1 mole here produced, 2808. What happened if we have 2.5? So we will solve this one. Okay, given the balanced equation here for the combustion of glucose and the amount of glucose burned, we can determine the energy released during the following steps. Number one, identify the energy released per mole of glucose from the equation. We see that the combustion of 1 mole releases what? 2808 kilojoule. The next step, calculate the total moles of glucose burned. We are given that 2.5 moles of glucose are burned. So we calculate the total released, multiply the energy released per mole of glucose by total number of moles burned. So the total energy released here equal energy per mole time number of moles burned. So we have 2808 times 2.5 mole, and we have the total released energy will be 7020 kilojoule. Therefore, when 2.5 mole of glucose are burned, we have the result 7020 kilojoule of energy is released. We can make cross multiplication. 1 mole of glucose give 2808. So what happens if we want to burn 2.5 moles of glucose? So it will release what? And make cross multiplication. 2.5 times 2808 divided 1 will giving the number of moles, will giving the energy here released when 2.5 moles of glucose, it will giving 7020 kilojoule. Okay, let's going to the next question. Question 5. Question 5 says that diphenyl oxalate, hydrogen peroxide, and rhodiumamine A are mixed together in a plastic tube. Okay, after a few seconds, the plastic tube begins to feel warm. Okay, so if we mix them together, you feeling warm on the plastic tube, and the resulting mixture start to glow a bright red color. What type of energy are produced by the mixture? Okay, so here when you're feeling hot, it will release heat and it will give a bright red color, so it will also giving light. So we have our choices here. We have light only, we have heat only, heat and light, light and electric, heat and sound. Okay, so the right answer will be letter C, heat and light. Letter C, heat and light. So our choice depend on it. When diphenyl oxalate, hydrogen peroxide, and rhodamine B or A are mixed together in a plastic tube, an interesting reaction occur. Let's break down the type of energy produced by this mixture. Heat, the first one, or thermal energy. The fact that plastic tube begin to feel warm indicate that heating is involved. As the reaction proceeds, energy is released, so it will be in the form of heat due to chemical reaction. The next one, light or radiant energy. The resulting mixture start to glow a bright red color. So this glow is due to the influence, where the energy changes in reaction don't always involve the release or absorption of heat. So the specific compound that responsible for this glow will be by 2,4,6 trichlorophenyl oxalate, TCBO, or the TCBO reacts with hydrogen peroxide. It produces an unstable compound called 1,2-dioxydione. This unstable compound readily decomposed into carbon dioxide, releasing the energy in the form of light or radiant energy. Rhodiumine B acts as a dye that enhances the visible light emitted during the reaction. In the summary, the mixture produces both heat and light energy. Other types of energy as kinetic energy are essential and relevant in this context. Okay, I hope you understand the questions. This is the last one for this group of questions. Inshallah, we will continue answer all the questions after that. Thank you for watching, and I hope you enjoy the way that we included in answering all these questions. Thank you and goodbye.